Next, let's take a look at the heat generation term in the weak form. That's this term over here. This is in general called a source term. So you'll see that terminology being used. And source terms have, it's basically a known function. And here, it's a constant, but it could also be a function. In structural mechanics, this could be gravity. So that would be a source term. Or in the wind turbine blade example that we will do, the centripetal acceleration is going to be applied in this way. It'll be a source term. And if we integrate this term, we have to do the integration again element by element. And let's do it over the first element. I can take q out of the integral. So I'll take q out of the integral and I'll say 0 to delta x. So delta x is that distance times, so the weighting function times dx. So it just becomes an integral of the weighting function, and that means that I need this integral will give me this area. And you can work out what that area is, and that comes out to be q. You'll get w1 plus w2 times delta x divided by 2. That's the area. And I can, split this into the part that depends on w1 and w2. So the part that depends on w1 is going to be q delta x over 2, and the part that depends on w2 is going to also be q delta x over 2. If I multiply this by a, which is equivalent to multiplying this by a, in fact, that's what when you do the procedure rigorously, that's what you would do it. This term, so the term q a delta x, so q is the heat generation per unit volume, and that's a volume, that's heat generated in the element. And in this case, that would be for any element because the element lengths are all the same. So this is interesting, right? That when you integrate that term, what happens is you can interpret that as the half of the heat generated is assigned to this and half of it is assigned to this. So if I divide this into 2, half of this heat generated gets assigned here and half of it gets assigned here. And similarly for element 2, half of this will get assigned here and half of this will get assigned here. And so when you work it all out, what happens is that for w1 you'll get only one contribution, so it'll just be q delta x over 2, plus for w2 you'll get two contributions, this one from the first element, and then you'll also get a contribution from the second element. So that'll be q delta x over 2 plus w3 and so on. You can work it out. And let me go back to the, I showed all the equations that were multiplied by the weights. So you can see how this term comes about. Okay, that's half of the contribution here. You can see how this term comes about. That includes both of these contributions and so on. And if you write this in this form, that's the stiffness matrix form, this is how it's usually written. By the way, I noticed that I've called early in one of my earlier slides, I called this Q and now I'm calling it F. Sorry about mixing notations on you. It's the same thing. But what this means is that the heat generation or the source term is going to affect all the rows of F because it appears in all the equations. This is in contrast to this term that's going to affect only the equations at the boundaries. So that gives you some insights into how the source term gets incorporated into the algebraic equations.